Okay, here we're going to put all of our binomial knowledge into effect on this exam question. So, first thing we've got to do is read the question, check it is binomial. Binomial questions tend to be the ones in the exam that don't declare themselves. You have to spot that you're counting successes in an independent trial. So what's going on? We are looking at how many mornings something happens for. So we're counting mornings when he wakes before his alarm rings, which is something that has a fixed probability of 0.4. So we're counting the number of, let's call this success, the waking before the alarm rings. So we're counting the number of successes in 7 mornings. That's a fixed number of independent in their trials. So we have got a fixed number of independent trials. The probability of success is fixed, okay, and I am counting the number of successes. So I can say that the number of mornings he wakes early, let's call it x, is a binomial. The value of n, the number of trials, is 7, and the probability of success is 0.4. And so therefore in part A, all I need is the probability that that happens 2 or fewer times. So that's the probability that x is less than or equal to 2. Okay, but I'm always going to visualize this by thinking of all the outcomes. It could happen no times, it could happen up every time in the week up to 7, and I'm interested in outcomes around about 2. So put our dots in. So on 2 or fewer mornings, so it could be 2, it could be 1, it could be 0, but it couldn't be any of these. So my box goes there, so I'm interested in values of 2 and below. So I go into binomial CD. So that's 7, second screen, binomial CD. Put my values of n in, so it was anything up to 2. Put in my value of, x was anything up to 2, my value of n, 7 mornings in the week. The probability of waking early a given morning is 0.4. So my calculator tells me that probability is 0.4199. So, 0.4199. Now it would be nice if the booklet had given us enough space to write this out properly. I don't approve really of writing out answers to exam questions all squashed up like this. Okay, so I'm going to use some margin space for part B. Okay, this is more than 1 but fewer than 5 mornings. So I have my list again from 0. Okay, 1's in play, 4, 5's in play, 6 is in play. So there's our list of outcomes. More than 1, so I can't have 1, I can't have 0. 2 I can have, that's more than 1. Fewer than 5, so I can't have 5, but I can have 4. So the ones I want are from 2 to 4 inclusive, so I need to go all the way up to 4. And I need to then take away these ones I don't want. So I need the probability of x being less than or equal to 4, take away the probability of x being less than or equal to 1. So I can get my calculator to tell me those probabilities. Okay, so for 4, okay, n and p are still correct, so I just change x to 4. So that's a probability of 0.9037, 0.9037. Next number was 4, minus the probability of x being less than or equal to 1, so change that to a 1, and it gives me 0.15863, 0.15863. Take those two probabilities away. Here we go, that's the correct subtraction, and we get 0.7451. 0.7451 to 4 significant figures. That should do me. Okay. Now part C. Okay, exactly 7 mornings. Okay, so for this one here, I'm going to continue using binomial CD. So it could be the outcomes are 0 up to 7. I'm interested actually just in 7, not in any of these. So I'm going to need to work out the probability of being up to that 2 or equal to 6, and do 1 minus the probability of x being less than or equal to 6. Okay, so on my calculator I'll have to go back into a binomial CD. So 7, second screen, binomial CD, and I need to start again with x is 6, anything up to 6, n is 7, p has always been 0.4, and I'm getting the probability of 0.99 836. So I need to do 1 minus 0.99836, which is 0.00164, which I think is correct to 5 decimal places. So even though it's only 3 significant figures, I think I'm going to be alright giving my answer like that. And then finally, part D, we need the values for the expected mean. Again, the expectation or mean would be a normal way of saying, more normal way of saying that. Never mind. Find the values for the mean and the standard deviation for the numbers of mornings in that should definitely be week, when Aaron wakes before the alarm rings. So, expectation and standard deviation, we need the formula for the mean, which we can call E of x. And the formula booklet tells me, so page 11 of the formula book is the one that you go to. Okay, you've got the binomial distribution on the top row. Okay, so for a binomial distribution, the mean is NP, the variance is this. So when it mentions expectation, then we know we need NP. When it mentions variance, we need this. And we're doing standard deviation in this question, which isn't this exactly, but is based on it. So I can quote the formula. Okay, that the expectation of x equals NP, and N and P are what they were from the very start of the question. Okay, N has always been 7, P has always been 0.4. So we're going to do 7 times 0.4, which is 2.8. Okay, and for the variance of x, okay, is NP 1 minus P, which will be 7. Times 0.4 times 1 minus 0.4, which is 0.6. So if I do that calculation, 7 times 0.4 times 0.6 equals 42 over 25, which is 1.68. But that is not the standard deviation, that's the variance. The standard deviation is sigma. This is sigma squared. So I need to do the square root of that answer to get the standard deviation, which is 1.296. Okay, so I've worked out the mean and standard deviation using those formulas. Now I've got a bunch of frequency data, and I've got to get the mean and standard deviation for the data from the data for the table. So this is now going into the calculator again. I want mean and standard deviation of sample data, so I'm going into statistics mode, and I need 1var mode, and I need to enter my frequency data into here, which I've now done. So I go into option, 1var calculations, okay, and it's telling me an x value there of 2.8, sorry, an x bar value of 2.8, okay, and on the next screen it's telling me N is 50, that's good. It's telling me an Sx value of 2.268. Sx equals 2.268. Okay, so I now have to look critically at those values. So state giving reasons whether your answer to part E supports Aaron's belief that the probability is independent from one morning to another. Okay, so why would that be relevant to these values? Because the alarm being independent, or the waking up, not walesing up, the waking up being independent, okay, is one of the conditions we needed to set up this binomial distribution. So this distribution is on trial. Do we believe it really is binomial or not? Well, if it was binomial, it would have a mean of 2.8, and it would have a standard deviation of 1.296. Now, it turns out the sample data has got a mean of 2.8. Well, that's good. But the standard deviation of the sample of 2.268 is quite a long way away from what the standard deviation would be for binomial. So we're going to say 2.268 is a long way from 1.296. So, well, we could say probably it's not a binomial distribution, but we're going to cut to the chase and say we think it is unlikely that his belief is correct. So Aaron's belief is unlikely to be correct, because if it was correct, if it really was independent, then the binomial model should be a lot better than it seems to be. It would be a better match to these observed numbers from the data.